I would call what's up on the screen here now as custom home building or fine home building, right? You're not going to see a whole street of a whole row of houses on a suburban street being built this way. You know, this is custom. This is one-off construction, and I'm guessing it would be priced accordingly. If you drove down a street in newer suburbs, let's say you drove around in Naperville or maybe something a little further out, and you started to peel back how those houses were put together, my guess is you would find something like this, right? This is more common construction practices, more economical construction practices, as opposed to that which is a custom practice. Now, when if any of you get into ARC 108 or 110, we start to talk about how do we take these more standard construction practices and make them more efficient. Right, in my 110 class, I talk a lot about climate change and how we in the construction industry have to build buildings, build houses that are more efficient, more energy efficient. So that's part of our challenge here. How do we take the techniques that our tradesmen or tradespeople know and adapt them to more efficient, producing more efficient buildings? So any questions, folks, before we get going again? Okay, well, you're quiet. Hopefully that means that doesn't mean you're all doing something else. Right, post and beam framing, again, this would be more of I would deem it custom construction, right? A sound investment. Yeah, to me, if you have this property, if you have this site on a lake in Wisconsin that you own, yeah, that's a heck of a good investment because they just don't make that many building sites like this. So if I happen to need a house in a place like that, I'd probably consider something like post and beam. Right, because of the strength of those timbers and their dimensions, right? We don't have to frame we don't need studs every 16 inches or every 24 inches on center, right? We can open that up. And as the architect, you can do lots more things. But again, it comes at a price, right? The price is one that not every homeowner is going to be able to afford. I don't know about susceptibility to rotting. Again, I would say pros and cons are appearance and cost. Looks great, costs a lot of money to build. Not everyone could afford that sort of thing. Yes, Nicole.
So, as you were flipping back and forth to that one picture, I kept wondering. Well, what came to mind was Frank Lloyd Wright, and he didn't have a lot of second story homes, at least that I'm aware of, but they were sort of open. Would his architectural style also fall into this post and beam framing kind of category?
That's a good question. He certainly didn't. He didn't draw attention to the structure the way that this designer is doing here. So
Right.
I'm guessing that his buildings were probably framed more conventionally than what is shown here. On the other hand, a lot of his structures did have kind of daring cantilevers. So there is steel hidden away someplace that he used to create those cantilevers, right? If you've gone down to the south side of Chicago to the Roby House, right? I think there's some cantilevers in that building that could not be executed with wood. I think that there is steel in there that holds those cantilevers up. Same for the falling water, the one that juts out over the waterfall in Pennsylvania. So I think he was hiding what he was doing. He wasn't trying to call attention to the structure. He was creating different effects.
Okay. Thank you.
Oh, you're welcome. Right. So again, here's kind of a cutaway of what post and beam construction might look like. Again, getting back to the Amish and an Amish barn raising, they're likely using techniques like this. But again, not every contractor, not every carpenter is going to have the skills or experience necessary to do something like this. Right, here's a crane in place, lifting those heavy members up. This hard to tell. This might be hard to tell whether this is a residence or a small commercial building. It might be a residence. But again, to me, this speaks of more custom construction than everyday residential construction. Well, we'll get into this more if we have a chance at the end of this semester or in 108 and 110, but we have a number of ways that we can make our buildings more efficient. One of them would be if we have that double header, not the double header in baseball, but the two headers that carry the load over the door and window opening. One way we can make that structure more efficient is by adding some insulation between those headers to reduce the heat loss through that structure here. Now this makes sense if we're going to get away from 2x4 framing and go to 2x6 framing. Right? So then if we have two, say 2x6s or 2x8s forming our header back to back, that's going to bear on 2x4s. So we need a 2x6 wall stud if we're going to actually use these insulated headers. Again, these are advanced or high performance framing techniques. Again, here's a picture of a insulated header. Again, a little hard to tell here, but I'm going to guess that's a 2x6 and not a 2x4. Here's typical practice for framing a stud wall. So this would be the wall in a platform frame construction. And since we have, oops, my water glass eluded me here. Since we have openings in this wall, we have to have headers to carry the load above the opening, just like we talked about with lintels in masonry construction. Here's our header above the door opening or the window opening. And we introduce a couple of different additional terms here to talk about the different types of framing members. that occur in this situation, right? So here's our sole plate, which we saw before, our regular conventional stud. Here's our double top plate. But now with this opening, we have two different types of studs. We have our regular stud, which is the king stud, and the trimmer stud, which is holding up the header. And under the bottom, we have another stud that has to hold up the sill, and this cripple that's holding up the sill as well. So where did all these names come from? I don't know, but those are the terms that we need to familiarize ourselves with. And this, no, I think the terms, Vaughn, the terms are not used interchangeably. I think typically the trimmer is what's holding up the header, and this cripple is this little short member here that's holding up the sill. I don't see them used interchangeably. And this picture here is figure 2-12 in the textbook. Actually, it's explaining the difference between trimmer and cripple. The text on page 212, let me glance at it quickly. So please, it says in here, the text on page 212 talks about cripple studs. They're similar to trimmer studs, except that they're not paired with another member, right? So in this case, the trimmer and the king stud are paired together. This member here, the cripple stud, is not paired with another member. So I think that's why it has a different name. Again, I don't know who made all these names up. I'm sure, over the years, these names got applied to thing, and then we, as kind of folk art, and these names kind of stuck and carried forward in the construction business. So again, a lot of terminology related to how we frame in residential construction. We don't necessarily see analogous terminology in steel or concrete masonry construction, right? We don't have cripples. We have lintels that bear on a piece of masonry, but we don't have some of this terminology in steel or masonry construction, right? So here's a picture of some interior frame construction. Here's our bridging, right? This is lateral supports. What we're trying to prevent is when this stud is placed under load, right? When there is compression, it's going to have a tendency to bow or bend outward as it responds to that load. So to prevent that from happening and to maintain the compressive strength that we're looking for in this member, we have this bridging here that prevents these members from bowing. We don't, in our reinforced concrete, we worried about tensile strength, but in this case, all this partition is doing is either A, holding itself up, or potentially transferring load from up above down below. Here's an example of a section of a residential building. It seems kind of custom and fussy to me. But again, we see the different elevations being shown. Again, no different than what we would see in a building section for commercial construction. Let's talk about roofs. To see how roofs are framed, we have to picture what they look like in 3 dimensions. You know, what are going to be the most common roof styles are going to be a gable roof or a hip roof. So keep those 2 pictures in mind. Again, like lots of things in architecture and construction, there's a bunch of terminology to familiarize yourselves with. Right, here's another set of images. Right, we're taking, this is useful because you can see our standard gable or hip roof and showing what happens when we cross it, right? We ended up with a cross gable or a cross hip. And we could certainly pair these 2 things together, right? We could have a hip roof on one end and a gable on the other end, or a hip roof and a dormer. But as we see when we start to look at how these things are framed up, you see where the things such as the valley come into play. The hip or valley. We'll see that in a minute here. We can frame the roof in a couple different ways. We could use a roof truss. I think in both Sullivan and Marseille, it referred to roof trusses. So roof truss would be a prefabricated or a member that's built in the shop and brought out to the job site, as opposed to the roof being framed on site. Rafters are the angled members, right? So these would be the rafters. In all these roofs, there's going to be rafters, angled members supporting the roof, typically going to be 2x6 or 2x8 or 2x10, depending on the spacing and also the pitch. Surprisingly enough, in the house that I live in is a fairly steeply pitched roof, and our roof is framed with 2x4s, not 2x6s, 2x4s, 16 on center. Of course, it's old growth wood, so it's likely a lot stronger than the wood that would be available today. Ridge board would be the horizontal member at the peak of the roof where those 2 rafters come together. Collar is going to be any horizontal member that helps tie the rafters together. So let's see what that looks like. Oh, a few more terms we gotta contend with here. Always lots of terms. So we have rise and run. So the rise is the vertical distance between the top plate and the ridge board. And the run is the horizontal distance from the wall supporting the bottom of the rafter to the ridge board. And slope is that relationship between rise and run. Span would be the total distance between supporting members at that rafter or truss supports. And depending on how we frame it up, we might have a couple different custom cuts that the carpenter has to make in the field, the bird's mouth being one of them, where that rafter fits or bears on top of the stud wall. I should have mixed up text and pictures a little better here. My apologies. We have common rafters, hip rafters, and valley rafters. So let's look at the picture and then we'll go back to the text, because once we see a picture, a lot of these terms will make a lot more sense. Jack rafters, purlins. Okay, sorry about that. That's hard to see. Boom, here we go. All right, so here is our rafter. And here's the stud wall that it's bearing on. Here's the bird's mouth cut where that rafter bears on the top plate of the stud wall. Here's our collar tie. Here's our ridge. And again, you'll see on another picture that, again, that a specialized cut needs to be made both at the ridge, and it's typically made down here. But here's our rise, right, vertical distance from top plate to the ridge board, and our run, wall to the center line or wall to ridge line, and rise and run is what we use to judge the pitch of the roof. Right, here's another picture that shows it again. Right, here's our common rafter. You have to make this plumb cut at the ridge board, a bird's mouth cut where this rafter bears on top of the stud wall, and in this case, probably another cut at the bottom, a tail cut here. So this could be a pre-manufactured truss, or it could be things that the carpenters are doing in the field. Here is roof pitch. This particular slide is using rise over span. You'll sometime, I think the next slide has rise over run. I'm more familiar with rise over run. But this is expressing a way of expressing the roof pitch. And we'll see how that shows up on drawings. Right. Here's rise and run. We typically talk about rise over run. So how high does the roof rise over a given distance? So this would be a 5/12 roof slope or roof pitch. And putting that into some context, right? 4/12 or 5/12 is common. We seem to, in newer construction, we've and again, I think you see this in Marseille especially, right? Gone to higher pitch roofs because we think that that looks cool, or I think it a lot of waste of space and material. The other is that if you're the roofer, you really have trouble trying to do a re-roofing job on a roof that's so steeply pitched, right? You can't walk up and down something that's pitched like this. You got to be tied down. If we happen to have trusses, again, I think both Sullivan and Marseille show this truss profile, so it doesn't actually, we don't actually see the details of what the truss manufacturers provided in terms of the structural members, but we see its characteristics in terms of span. And from here we would get the rise. Right, here's this would be a 6/12 roof slope or roof pitch. Okay, just like we had a picture of the stud wall with various terms, here is a flattened out or looking down on roof framing and looking at the various terms. So here's our friend the cripple again. Right, so we have the common rafters, the ridge. Remember I said, let me jump back a few slides so you can picture a hip and a gable. Right, so this would be the hip portion of the roof, right? So we have a hip and hip jacks. This would be the gable. And where there's a gable, there's going to be a valley. So keep this picture in mind, and let's go back. Let me find the one that I'm looking for here. Boom, here we go. Right, so what we saw was, yes, I'm pointing with my mouse. Let me fix that and point with the pointer. Sorry. Is this any better? Can you see it when I use the little, sorry about that. I forgot to turn the pointer on here. They should give you the choice of which finger to extend with the pointer, but that's a whole different, that's a topic for another conversation. So again, you see our hip and our gable. So let's keep these pictures in mind and then go back and look at that framing. This little guy here is going to be the valley. So we have members related to the hip and members related when we have a gable. So let's go back and look at that. Sorry. It's the first time I've taught this class and used this slide deck. So I'm going to have to, if I do this again, I'm going to swap some of these images around a little bit to make it make a little more sense. Even though this is all appearing in 2 dimensions, right, these common rafters are actually, would be sloping down, right, from the ridge line down to the top of the stud wall. And these hips would be sloping down as well from the ridge line down to the, there's going to be a corner out here someplace that these hips are sloping down to, and the hip jacks are sloping down. And again, this gable will be a little bit different, right? Because if I stood on this, turn the pointer back on here. Let me see if I can blow this up. Sorry about that. That's not doing much good, is it? Right, if I stood in elevation and looked here, I would see this gable would be a flat wall surface. If I stood on this side and looked at this in elevation, I would see a piece of roofing, right? So let me go back and see what that looks like. Ooh. Right, so here would be our gable end in elevation is going to look like this, whereas looking at the end or looking at the hip roof in elevation, I see something totally different, right? In elevation, I see roofing on the hip. In elevation, I see a vertical wall surface on the gable. Again, particular terminology related to how that gets framed up. If you're the carpenter or the general contractor, you're going to know all this stuff like the back of your hand. If you're the electrician or the plumber, you're going to pay a lot less attention to it. Right? Our goal here is to give you an introduction to all of these things so you have a broader understanding of how buildings go together, and then whatever role you play in the construction process, you'll have some understanding of what the other folks on the team are doing, and hopefully a very detailed understand of whatever role you play, you know, estimator or superintendent or project manager or electrician or carpenter or plumber, architect. Again, here's another image trying to put this roof framing into 3 dimensions, right? So this would be a hip roof. Here's our common rafters, our ridge board, right? Hip rafters. And anytime they're shorter than the common rafter, here they're calling them jack rafters. And this would be what the framing would look like when we have a, right, here's a hip over here, and this is a gable. And then as soon as we turn like that, then we end up with a valley as well. Okay, one more framing detail to talk about, and that is how we frame stairs. Right, so again, in stair framing, we have a stringer, right? That's the angled member that's running between the upper and lower levels that's supporting the stairs themselves. Typically, that's going to be a larger piece of lumber, 2x8 or 10 or 12, as it says here. And the tread, that's a member that forms the step. Right, so the tread is going to bear on the stringer, and the stringer is going to be supported by some other framing member. Right, riser. Right, so we have risers and treads, and run and rise. So let's look at this on pictures. Boom, there we go. I remember we had headroom and Sullivan. I think I had a Sullivan question on headroom. So here's our stringer. Again, that'll be the angled member that's holding everything up. Here's our tread and our riser, tread width, riser height, total rise, total run. Right, we always have stairs going up at a 45. One thing that's very interesting, our bodies, you know, when we walk up and down stairs that haven't been made well and we stumble, it's probably because these heights aren't consistent. I know when Francis and I first moved into our house here, with young children, our children were always falling down the basement stairs, and we're like, what the hell's going on here? Can our kids when our kids know how to walk up and down the stairs, except when I think Francis took out a tape measure and found that there was inconsistency in the riser height, so that made it hard to walk up and down the stairs because the riser height was only off by maybe half an inch or something. It wasn't a big change, but it was enough to kind of throw our kids off from walking up and down the stairs. Right, a couple of different ways we can do stairs, straight. Right, we quite often see this, right? Going up a set of steps to an intermediate landing, turning 180 degrees and then continuing up. I said before, we can also use metal members instead of wood members. So in this case, we have metal framing or metal studs. The way that they're applied is very similar to wood. Another, an alternate technique, but I find that wood framing is going to be far more common than metal framing in residential construction. But it could be used as an alternate material. It's more expensive than wood. There's probably a reason why we're continuing to use wood in residential construction, right? It's going to be cheaper and more common. Not as strong as wood. I'm not sure about that. Okay, well, I am running out of gas here, and we're getting to the end of our time together. Are there any questions? I have to say that at the end of a long workday, coming and teaching, sometimes I'm pooped out by the time I get to almost 9 o'clock here. So my apologies. I didn't have much of a chance to catch my breath between working and teaching here. So, any questions? You are a quiet group tonight. That could be a good thing or a bad thing. Thanks, Nick. Let's do this. I'm going to ask you. Good. Yeah, Vaughn, this might make a little bit more sense, right? Because you could probably relate more directly to residential framing than you can to commercial, right? This is gonna hit a lot closer to home, so to speak. Let's do this. If you guys could, between now and Thursday, do the test your knowledge on pages 221 to 223. So go through and do that work, and we will go through those answers on Thursday, as well as trying to tackle, I don't know if we'll get to all the activities, but tackle as much as we can of the activities. And again, looks like we get back to our friends at Sullivan and Marseille. So again, if you can do the test your knowledge, we'll go through the answers to that at the top of Thursday's class, and we'll break up and work on the activities. Any other questions, folks? Okay, we'll have Have a good rest of the evening and a good day tomorrow and Thursday, and we will see you on Thursday. Thanks, everyone.